In this video, we're going to look at approximating the area of a region using left-hand endpoints. So here our problem says approximate the area between the graph f of x equals x squared plus 1 and the x-axis on the interval from 0 to 2 using 4 rectangles and left endpoints. So let's draw our graph. So we have x squared plus 1. So that graph looks something like this. We are going from 0 to 2. Let's put 2 out here. We'll call that 2. And we're going to use left endpoints. So we need the first height is going to be defined here at 0. This is 0.5. Our next height is going to be defined by the function value at 1/2. The next height is the function value at 1. And then we have 3/2. So our area, right, so if we were to call this, I don't know, let's call this region 1. The area of that first region that is going to be 1/2, right? So the width of the rectangle times the height of the rectangle. The height of the rectangle is defined by the function value here at 0. So it's 1/2 times 0 squared plus 1, which is just 1/2. If this is region 2, the area of region 2 the width of that rectangle, again 1/2. The height of that rectangle is defined by the height at that left side. That left function, the left x value is 1/2. And so we're going to have 1/2 times f of 1/2. So we have 1/2 times 1/2 squared plus 1, which is 5/8. Then we have the area of region 3. The width again, 1/2. We have the function value at 1 is going to define the height. So there, we get 2 times 1/2, which is just 1. And then, for region 3, we have 1/2 as our width. Our height is defined as the function value at 3/2. And if you do that, you'll get 13/8. So if we're approximating the area under the curve all the way up to here, what we're going to do is we're going to take all of those regions, 1/2 plus 5/8 plus 1 plus 13/8. We're just going to add them up. So our total is going to be equal to 1/2 plus 5/8 plus 1 plus 13/8, which is 15/4. Great. Is this going to be an overestimate or an underestimate of the actual area? Well, in this one, because all of these rectangles are below the curve, when we add them up, we're going to be missing a little bit of area from each one of these. So those are going to underestimate the actual area. Great. Let's do this problem again, but instead of using left endpoints, let's do right-hand endpoints. And so here we have, let's draw our graph. So same interval, 4 rectangles, but now we're going to use right-hand endpoints. This is 2 out here. Here's 1, 1/2, and 3/2. So using right-hand endpoints, starting at 0, the first rectangle is going to be right here. We'll call that region 1. The second rectangle is going to be defined at the right hand of the next interval. And then the right hand of the next interval. We have region 1, region 2, region 3, and region 4. And so, what are we going to do? Well, our area is the total area is going to be approximately 1/2 times the function value at 1/2 plus 1/2 times the function value at 1 plus 1/2 times the function value at 3/2 plus 1/2 times the function value at 2. So all of those have a 1/2. So you can factor that 1/2 out if you would like. So we have 1/2 times our function value at 1/2 was 5/4. And so if you were to plug 1/2 in here, 1/2 squared is 1/4 plus the 1, it goes 5/4. Our function value at 1 is 2. Our function value at 3/2 is going to be, let's see, 3/2 squared is 9/4 plus 4/4 is 13/4. And then our function value at 2 squared plus 1 is 5. Add that up and multiply by 1/2. And we should get something that looks about like 46/8 or 23/4. Fantastic. Is this approximation, is that going to overestimate or underestimate the area under the curve in that interval? Well, this should be an overestimate. Of the actual area. I know this video is getting long, but let's do one more because we're going to work with the same same example. Let's look at some midpoints. Here, if we are using midpoints, here we have 2, here's 1, 3/2, 1/2. So our first rectangle, so from 0 to 1/2, we're going to take the height right smack dab in the middle, so that's right at 1/4. For the next rectangle, we'll take the height right smack dab in the middle of the next subinterval. That's occurring at 3/4. And so our width is 1/2. So that first one, right in the middle from 0 to 1/2 is 1/4. Right in the middle from 1/2 to 1 is 3/4. Our next midpoint here that's happening at 1 1/4 or 5/4. And our final midpoint up here that midpoint is 7/4. Perfect. So if we want to add these areas together, our total area is going to be approximately the widths of each of these rectangles. They're still 1/2 in width. Right? We can find that width. We could find that by taking 2 minus 0 over 4. So that's the width of our rectangles. And then we have the function value at 1/4 plus the function value at 3/4 plus the function value at 5/4 plus the function value at 7/4. And so we're plugging those values into this function. Those are defining the height of each of those rectangles. We're adding all those up times the width. That should give us the approximate area. And if we do that, we get something like 4.625. Is that going to be an overestimate or an underestimate? That's right, we don't know. What happens here is we get a little bit excess here, but we have a little bit under here, and we don't know how those are going to balance out. So it's unclear if this will be an overestimate or an underestimate. We feel like maybe it will be closer, but it doesn't necessarily have to be. Also with the over and underestimates, you might want to say, oh, so the left-hand endpoint is always an underestimate. That is not true. It's always an underestimate if you are increasing as you move left to right, because then your left-hand endpoints would always fall below the curve. But if you were decreasing as you move from left to right, then the left-hand endpoints would fall above the curve. So left-hand endpoints, they could be an overestimate or an underestimate, or maybe we don't know. Because here, if you have a curve, sometimes we could go above, sometimes we could go below. If it's not monotone increasing or monotone decreasing, we just don't know. We have to do more analysis. All right, come back next time and we will look to see what impact the increasing the number of rectangles would have. We will see you there.